You may think that the study of neural networks includes things like brains and neurons, but no. That's neuroscience. Instead, artificial neural networks use, well, artificial neurons. Artificial neural networks actually use two components. Perceptrons are the computational units of the network. Each has a threshold, in this case 1.5, and if the sum of the weights of the firing inputs is greater than this threshold value, the neuron itself fires. Axons carry the messages via firing and have weights, which are used in the method mentioned above. For example, in the network below, if just one input fires, the perceptron will not fire because 1 is less than 1.5. On the other hand, if both inputs fire, then the perceptron will fire as well. Perceptrons can also learn. Here is a perceptron simulating an AND gate. It uses the weights 1 and 1, and a threshold of 1.5. But how can these numbers be found in general? Here's how. Each perceptron and axon will change their weights and thresholds according to simple rules. They simply add or subtract a number, usually taken to be 0.1, which pushes the network closer to the goal, slowly. For example, here a network learns the NAND function. The end result, as seen here, is three numbers, 0.8, -0.2, and -0.1. These serve as weights in a NAND gate. Networks come in two different types, feed-forward and not feed-forward, shown on the left and right, respectively. Feed-forward networks are so called because their information travels in one direction, while networks which are not feed-forward have information loops. Here, a multi-layer feed-forward network simulates a simple logic gate. These feed-forward networks can be used in many areas. They can decipher messy handwriting, detect and mark spam, and even recognize faces, all with great accuracy.